Finding the surface area of cylinders with Adam Maths Tutor. Here are the beginner questions, some of the easiest types of questions that you're likely to find on this topic. The surface area of a 3D shape is the total area of all of the faces of the shape added together. To understand what lengths and dimensions to use, it's quite helpful to think about the net of a cylinder. It's made up of the two circles at either end and the curved area that wraps around the middle of the cylinder would form a rectangle when opened into a net. Let's write down what the area of these individual 2D shapes would be. To find the area of a circle, we can use pi times the radius squared, pi r squared, and we'll have to multiply this by 2 for the two circles at either end. In this case, the radius would be half of the diameter, which is given as 8 millimeters. So pi multiplied by 4 squared is 16 pi. It helps to keep things in terms of pi as long as possible to avoid any rounding errors along the way. Next, we can multiply this by 2 for the two circles, leaving us with a total area of 32 pi for those two circles. Lastly, we need to find the area of the rectangle. The dimensions of the rectangle would be given by this length, which is the distance between the two circles, which in this case would be the height of the cylinder and would be 7 millimeters. And we'd need to multiply this by this length, which is the length that wraps around the circumference of the circle once formed into a cylinder. So the length in blue will be this bit here that wraps around the edge. Therefore, we would need to find the circumference of the circle. The circumference is worked out by doing pi times the diameter, and therefore the area of the rectangle would be pi multiplied by the diameter multiplied by the height. Therefore, the area of the rectangle will be worked out by doing the length of the rectangle multiplied by the width of the rectangle, pi times the diameter multiplied by the height. The diameter is given as 8 millimeters, so pi times the diameter is 8 pi, and then multiplying this by the height would be multiplying by 7, which is 56 pi. The total surface area would be adding the two circles together and the area of the rectangle. 32 pi plus 56 pi is 88 lots of pi. And typing 88 pi onto our calculators and rounding to 2 decimal places is 276.46 millimeters squared. We can apply the same methodology to the next question, but there is a slight difference, and that slight difference is instead of giving us the diameter of the circle, they've given us the radius. So the area of the circle is pi times the radius squared, and the radius is given as 3.5. I wouldn't say it's any easier to leave our answer in terms of pi, so I'm just going to write them as decimals. If leaving your final answer to 2 decimal places, you'll want to leave all of your answers along the way to 1 more decimal place than that to avoid any rounding errors. So leaving this to 3 decimal places would be 38.484. Because we have the top and the bottom, we can multiply this area of the circle by 2, which is 76.969. The length needed for working out the area of the rectangle can be worked out by using the circumference of the circle. Circumference is pi times the diameter. This time, the radius was given, so we need to multiply this by 2 for the diameter. Pi times 7 gives us 7 pi, which is 21.991. Multiply this by the height of the cylinder, which would be the same as the width of the rectangle. So multiplying by 2.5 is 54.978, and adding 76.969 to 54.978 will leave me with the total surface area, which is 131.947. This can be rounded to 2 decimal places, which means my final answer should be 131.95 meters squared. On to the intermediate question with an increase in difficulty. This time we're finding the surface area of the cylinder, but we're giving our answer in terms of x. The method behind finding the surface area remains the same, but you'll be doing some calculations with algebraic expressions. The area of the circle is pi r squared. This would be pi multiplied by half of 6x to give us the radius, which is 3x squared. I'll need to consider this in a bracket to make sure that I multiply 3x by itself, 3x, and that avoids leaving it as 3x squared when really it should be 9x squared. And writing algebraic expressions, we tend to leave the multiplication sign out, so the area of one of the circles would be 9x squared multiplied by pi. Now because we have 2 of the circles, we multiply by 2, meaning the area of both of the circles would be 18x squared lots of pi. Next, we need the area of the curved rectangular face around the middle. When opened into a net, one of the lengths is given by the circumference that wraps around the edge of the circle, which can be worked out by doing pi times the diameter, and the diameter was given to us as 6x, so pi times 6x is 6x pi. Multiplying this by the other length of the rectangle, which is given by the height or the distance between the circles, and is 5x, leaving us with 5 times 6, which is 30, x times x, which is x squared, lots of pi, and the total surface area can be worked out by adding the area of the circles and the area of the curved rectangular face. So 18x squared pi plus 30x squared pi gives us a total of 48 lots of x squared pi. On to the advanced question, one of the trickiest questions that you're likely to find on this topic. This time, some of the lengths and measurements are given to us as exact values or surd form. We've actually been told the surface area of the cylinder, and the expectation is that we work backwards to find out what the height of the cylinder is. They have told us that the cylinder has a radius of 4 root 3, so I'll just label this onto my diagram. This provides me with enough information to work out the area of the circles at the top and bottom, since all I need is the radius. So pi times the radius squared, and the radius is given as 4 root 3. This would be the same as pi multiplied by 4 times 4 is 16, and root 3 times root 3 is 3. Pi times 16 lots of 3 is the same as pi times 48, and this gives me 48 pi. Because we have two of the circles, I can times this by 2, leaving me with an area for both of them of 96 lots of pi. Working backwards, I'll need to take the area of the circles away from the total surface area to leave me with the area of the curved rectangular face around the middle. So that would be written as 56 pi root 6 subtract 96 lots of pi. And to work out the height, which is one length of the rectangle, I would need to divide by the other length of the rectangle, which is the same as the one that wraps around the edge of the circumference of the circle. And the circumference of the circle is worked out by doing pi times the diameter. The diameter would be 2 lots of the radius, so 2 lots of 4 root 3 is 8 root 3, meaning this length would be 8 pi root 3. So the expression I had for the area of the rectangle can now be divided by one of the known lengths of the rectangle, 8 pi root 3. This would be the same as 56 pi root 6 divided by 8 pi root 3. 56 divided by 8 is 7. Pi divided by pi will cancel, and root 6 divided by root 3 is root 2. And then subtracting 96 pi divided by 8 pi root 3. 96 divided by 8 is 12. Pi divided by pi will cancel, and we're left with root 3 as the denominator. This is now moving it into the same format that we had been asked to leave our answer in. We can see that we already have something lots of root 2. And the last thing I need to do is leave it in terms of something lots of root 3, which I'm almost there with, but root 3 is written as the denominator, so I need to rationalise the denominator by timesing the top and bottom by root 3. So I get 7 root 2 minus 12 root 3 over 3, leaving me with my final answer of 7 root 2 minus 4 root 3. Before you go, take a look at this solution which I've provided. Spot the mistakes. See if you can tell me what they are, or make some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with maths or finding topics difficult, you can subscribe and turn on notifications to receive regular updates about new video tutorials. Don't forget to visit my website adamonlinetutoring.com for a full searchable list of all topics with exams, questions and solutions. You can also visit me on social media using the handle @AdamMathsTutor on Instagram, TikTok, Facebook and Twitter. All links in the description below.